Okay, cool. So now we are going to start. We are going to start with the class. And yeah, I hope I'm visible. I hope my screen is okay. Annotations already. Okay, guys, please don't annotate. One second, let me just disable that. Okay, there you go. Okay, so uh, today we are going to be going over STL, C++ STL. This is just an overview. And let me tell you some stuff at the beginning itself to clarify. First of all, this is just an overview. As I said, this is just an overview. We are not going to go in depth, a lot in depth into anything because, we don't have time and I want to give an overview of all the C++ things. You will be able to use them all, right? You will be able to use them all and you will be able to apply all of them if necessary, but you won't have a very deep understanding of it. I'll say this right now. But one thing is, I will be providing resources so that you can learn about all the topics today in depth. So all the topics today in depth can be learned better through some of the resources that I will be providing. Okay, that is one thing. Second thing, I will be assuming to some extent that you guys already know C++, right? I'll be assuming that you guys already know the basics of C++. This was also probably mentioned in the announcement. So yeah, just keep that in mind because if you don't know C++ at all, you might have some trouble following this class. Okay. And third thing, feel free to ask doubts. I mentioned this already, but feel free to ask doubts at any point. And yeah, just ask doubts, right? I will make sure to answer them. Okay, cool. Now, shall we start? Is everyone ready? You can let me know in the chat with a +1 if everyone is ready. Okay, cool. Cool then. So let us go through the goal of today, right? Our goal of today is to first of all learn about containers. So we are going to be learning about something called containers in STL. We'll discuss what STL is in just a second. Basically, containers are okay. You know what? I'll just swap this around for a second. Okay. So, well, containers are basically a class, right? You might not know classes, that's okay. But basically, it's just a collection of elements. Containers are collection of elements. It's just like a container in real life. Let's say you have a bucket. In the bucket, you can put a ball. You can put, I don't know, if you're brave enough, you can put your laptop in there. And you can also pour some water in there if you really wanted to, right? So those are containers, right? So basically, containers are things that just store, well, stuff, right? Now we have different types of containers like pairs and vector. We also have sets and maps. These all do different things, right? These all do different things. And in fact, sets and maps actually have variants. Now, after that, we are going to go over some functions. So we are going to go over some functions. And most importantly, we'll go over inbuilt binary search. So in case you don't know binary search already, you will be able to utilize the inbuilt binary search of C++, right? So that is another thing. That's something that we'll be going through. And finally, if we have time, because I'm not sure if we will have enough time, I don't want to make the class way too long. So if we have time, we'll be going over some functions. So we'll go over some STL functions. And again, if there is no time, do not worry. I'll share some resources such that you'll be able to learn about it. Okay. So this is our goal for today. Now, let us quickly discuss STL. I know you guys don't really like history and stuff, history or, other stuff. But yeah, we do need to know about this, right? So standard template library, aka STL, is a set of C++ functions or classes to perform various tasks, right? This is the definition of STL, right? Now, basically, there's a wide variety of functions, like wide as in really wide. There are over like 100 or something, functions and classes in STL, classes as in, I mean, containers for various different applications. There are so many things you can apply this for, right? And there are just a ton of them in STL. It's spawned through like years and years of C++. There are a lot of things that you can utilize. Generally, it's not necessary to know all of them because you will not be using all of them. You will only use the most important ones, right? So that's what we are going to be going over today. We are going to be going over the most important classes, especially classes because they are very common, and we'll also go over some functions, right? And again, most importantly, binary search. Now, the reason that we use STL over other things is because STL is way more efficient, right? STL objects are way more efficient, bug free. I mean, efficient as in, the developers of C++, I'm sure they'll be smart enough to optimize the code into like, literal perfection. So yeah, that is one thing. It will be efficient for sure. Second thing is it will be bug free because it has been, created over years and years and years, right? And people have used it for a long time. And so they will know if there are any bugs. And the third thing is that it's much easier to use than custom implementations. So custom implementations, as in if you write your own code, then that will take way too much time, right? That will just take so much more time than you just using what's already inbuilt, right? So for these reasons, STL is far easier to use, far better to use. So if you have a chance to use STL, feel free to use it, right? So yeah, just keep that in mind. Okay. So this is the reason that we use STL, and this is just the general definition of STL. Now, with that in mind, we can move on to the easiest STL container, a pair. As the name suggests, it is useful when you're dealing with two related values, not necessarily even related, but two values, right? Let's say you want to store two values, exactly two values of any data type, right? It might be of one data type or another. I do not really know, right? In which case, pairs can be used, right? So basically, a pair, this is a pair. You have values A, comma B. Now, A can be of any data type. For example, it can be an integer. Now, B can be of any data type. For example, it could be a string. Right. So these are pairs. Pairs have two values in them. And yeah, you can just use them to store related values. Generally, you store related values. And the main advantage of using pairs is that they have inbuilt comparators. What that means is they have already have their inbuilt lesser than and greater than implemented. Right. And they are compared in a very simple way. Let us say we have AB, pairs AB and CD. Right, let's say we have two pairs like this. Now, when you're comparing these two pairs, let's call this P1 and let's call this P2. Right. Now, let us say that you are going to compare P1 and P2. So you take P1 lesser than P2, for example. Now, this will be either true or false. Right. We know that this will either be true or false. Now, how does it compare? So it compares by checking the first two values. So when you take P1 less than P2, it says is A1 less than, A less than C, right? So it's comparing the first two values, like the first value of each, right? So it takes A, it takes C, it compares A and C. Now, if A is lesser than C, then it immediately returns true. If A is greater than C, it immediately returns false, right? And if A is equal to C, something else happens. We'll discuss that in a second. But let us say that this was equal to something like 1, 4, and this was equal to something like 2, 9. Right. Here you can see that 1 is lesser than 2. So when this happens, when P1 less than P2 is checked, A less than C will immediately be equal to true. Right. Because 1 is less than 2. That is true. So it will immediately return true. So P1 less than P2 is true for this case. Now let us say this was a 3 instead. Right. In this case, again, P1, like P1, in P1, if you take 3 and P2, if you take 2, well, A is greater than C, right? If you take A and C respectively, A is greater than C. So this will immediately return false. So P1 is not lesser than P2, but rather greater, right? And if they are equal, let us say they are equal, then what will happen is that it will compare the second two elements. So it will do the same thing with the next two elements. So here it will return true, here it will return false. And if they're equal, then it does something else. So it goes into the, goes to the next value, right? Instead of A, C, now it will take B and D. It will take B and D, right? So if A is equal to C, then it will take B lesser than D. So if we have 2, 4, 2, 9, then it will say that, okay, 4 is lesser than 9. So this is true. P1 less than P2 is true, right? And then, okay, one second, let me scroll down to the chat because somehow something happened. Okay, yeah. So B less than D will be true. Now, if we take, instead of 4, let's say we took 10. Now 10 greater than 9 is true, right? So we'll say that P1 is actually greater than P2 in this case, right? So P1 greater than P2 is true in this case because 10 is greater than 9. So it will return false. But if B is equal to D, Since we are taking lesser than, this will also be false, right? Since we are taking lesser than, we'll say that, okay, if it's equal, then it's not lesser, right? So if both are equal to 29, then it clearly means that nothing is lesser than the other. Okay, so they are both equal. So P1 is not lesser than P2. Hence, this statement is false. Okay, this is called also the lexicographical ordering. Okay, does this make sense to everyone? Lexicographical ordering. Okay. If anyone has any doubts regarding this part, please do let me know in the chat. And if this is clear, let me know with a +1. Oh, also this is known as the dictionary order, though it applies more for strings. This is also called as dictionary order. Okay, cool. If this is not clear, you can let me know. Feel free to let me know at any point, whatever your doubt is. Okay, fine. Now, cool. So now if that is clear, let us take a look at some examples quickly. Right. Let's take a look at some examples quickly. Is the screen size visible to everyone? Like, is the font visible to everyone? You know what? I'll just make it a bit bigger. Make it 23. Yeah, that should be fine. Okay, perfect. Now we'll have pair int comma int, let's say p, right? P, let's say p1 and p2. Now to access the first value of a pair, now to actually first of all to initialize it, you just take 1 comma 2 equal to 1 comma 2 equal to 3 comma 4, something like this. And obviously, as I said, also ignore this x and y here. This is added by cline. So cline automatically adds this for me. And actually, let me just disable it for now. Yeah, so that it's not confusing, I'll just disable it. Okay, now we can also have pair string, comma, let's say float, something like this is also possible, right? I won't show any examples of that because, it's just a very niche case. That can still be something that you can, that you can. So I'll just make this simpler. Wait, is P1 less than P2 true or is it false? Okay, Raji says it's true. Anyone else? Okay, Dilshad, actually, this is true. Everyone is correct. Whoever is saying one, you are correct. Unfortunately, like this is not greater, right? Like, this is not greater because first, as I said, it takes the first value. It takes the first value and then it compares the first value, right? So it compares, let's say we had 1, 2, 3, 4. That's what I had here, right? Now what happens is it compares the first value. It sees that 1 is lesser than 3. So P1 lesser than P2 is actually true, right? P1, which is 1. Over here, P1, the first value of P1, which is 1, and the first value of P2, which is 3, it compares them. Now, and it says 1 is lesser than 3. So this statement is true. So that's basically how it goes, right? So it goes like this, and it says that P1 is in fact lesser than P2. Now, to get the first value, all you have to do is take P1 dot first, and to get the second value, P1 dot second, as simple as that. And you can do the same with the other two. So you can just take this. You can say P2 dot first and P2 dot second, right? I just output this in a nice way. And if I run this, there you go. It outputs 1, 2, 3, 4, right? So I'm taking the first value of P1, which is 1, second is 2, so first value of P2 is 3, and second value of P2 is 4. Okay, there you go. So that's pairs, right? That is pairs. And honestly, there's not much else to discuss about this, right? Okay, cool. Anyone has any doubts regarding this part? I'll just wait for a second. If anyone has any doubts regarding this part, please do let me know. I'll just wait for like 10 seconds. Okay, cool. So hopefully that's fine then. Okay, actually, Ishan says if P1 dot first and P2 dot first are equal, then second value will be checked. That's exactly right, Ishan. That's exactly how it works. If A less than C, then it will figure out the value. If A greater than C, it will figure out the value. If they are equal, then it compares with the second value. Only when they are equal. And as you can probably imagine, you can figure it out for lesser than or equal to and stuff, right? When it's less than or equal to, again, the same thing happens. When it's equal, here, when B equal to D, this will be true. Nothing else will be changed, right? When B equal to D, this will be equal to true. And as you can probably imagine, greater than will reverse all of these signs, and you can figure that out. But yeah, this is the general idea. Okay, cool. Now, the next thing that we are going to be going over is vectors. Now, you might know about arrays already. And if you know about arrays, then you know that arrays store a collection of data, right? So arrays store data in a particular order, right? They have indices and they store all the data in a particular order, right? That's how arrays work. But one issue with an array is that they are not they are not expandable, right? Contiguous order, yes, exactly, Shubham. So arrays have a continuous order, like they don't. What just happened? Okay, so they have a continuous order, and they don't, randomly change their values or whatever, right? So arrays have a continuous order, and well, they just have a particular order. You can index them, and you can do all of that. And the only issue with them is that they are not expandable, right? If you have array with 10 values, then you're fixed with 10 values forever. That's it. You are just stuck with 10 values now, right? So what we can do instead is use a vector. Now, the advantage of vectors is that they store an ordered collection of data like arrays. It's basically like everything that an array can do. And exactly like Saumadeep is saying, and like Manoj is saying, it is dynamic in nature. Exactly. So it's dynamic in nature, which means that you can change the size of vectors, right? Now, if you take an example for that, let us say if you had an array A of 10 elements, you do it something like this, right? Let me just get rid of this unnecessary stuff. Also, let me just simplify this a little bit. One second. Okay, I'll actually use bit slash std++.h. But yeah. Okay. So if you have an array of size 10, then this is stuck with size 10 forever. Right. So this is stuck with size 10 forever. And if you have a vector on the other hand, vector in Shubham, I will be doing that. Okay. So if you have a vector, now one small thing about vector, please do not create the size of the vector like this. This is not correct. This is not correct at all. Please keep that in mind. What this does is it creates an array of vectors. It creates an array 10 of 10 vectors, right? This is an array. It creates an array of 10 vectors. Sorry, Nitish? Could you please repeat that once, Nitish? Sorry. Okay, never mind. Yeah. So this is not correct. Just keep that in mind. Now, the next thing is that if you have a vector, then you use a parentheses to create the size. So this is correct, right? This is wrong. You cannot do it like this. You cannot say x of 10 like this. This is not correct. You can put v and in parentheses, normal parentheses, you put 10. And this creates a vector of size 10. This is similar to how an array of size 10 is created, right? So you create a vector of size 10 over here. Now, initially, all the values of the vector will be 0. Initially, all are 0. And, well, you can change a value like this. You can just take your v of 4 equal to 10, something like that, right? So if you do v of 4 equal to 10, then it says that the fourth index will be equal to 10, right? And Abhishek says the square bracket creates an array of vector, right? Yes, that's exactly right. It does create a 2D matrix. Yes. Yes, Yash Gupta. That's exactly right. Okay. Now, v of 4 equal to 10, basically it changed the fourth index. And one more thing, this is also zero-based indexing. So you have 0, 1, 2, 3, and so on. So 4 is actually the fifth element. 0 is the first element, 1 is the second element, 2 is the third element, 3 is the fourth element, and 4 is the fifth element, right? That's one thing that you should keep in mind because, this is consistent with the entirety of C++, by the way. So generally, all the values start with 0, not 1. Okay. Now, Well, let us try printing the vector. Right. Let's try printing the vector. And to do that, I'll show you maybe a cool way to go through it in case you didn't know. You can take something like this. You can take auto IT, which stands for iterator. You can name it whatever you want. Obviously, it's just a variable name, colon V. And now let me briefly explain what it does. We know how, one second, let me disable this as well. Let me just disable all the hints for now. Okay, there you go. Yeah. Now, this variable goes through the values of V. This goes through the values of V. Right. That's one thing to keep in mind. This does not go through the indices, not the indices. Now, if I see out var, and let me output a space every time I output it, and then let me output an endl at the end. This should output 10 zeros, right? That's what I'm expecting. This should output 10 zeros, and that's exactly what I get, right? Initially, the vector is filled with zeros, so it outputs all zeros. Now, if I say vector of 4 equal to 5, something like this, then the fifth element will become a 5. And that's exactly what happens, right? So the fifth element becomes a 5. So that's how a vector goes, right? And as I said, you can do pushback, pop back. So you can do vector dot pushback, let's say 11, which would add an element at the end, right? It would add 11 to the end of the vector. So if I run this, you can see that it adds 11 to the end of the vector, right? Now, Jay says explain the difference between going through values and going through indices. I believe in case of vectors, both are the same or are they different? Now, that's a good question. If you go through the indices, then the only disadvantage that you have is usability, right? So if you can take for int I equal to 0, you can take I equal to 0, I less than v dot size, I plus plus. And every time you use it, you can say C out, for example, v of I. Right. You can do this, but the only difference is this is far simpler than the top one. Right. What do you think is easier to code? Top or bottom? So if I say auto I colon V and I output I like this, is this easier or is this easier? Obviously, the top one is harder, right? Because it's a lot more verbose. You have to type a lot more. So the bottom one is much simpler. So that's why we use directly going through the array values like this, array or vector values. Now, obviously, this also applies to arrays, by the way. So if I have this equal to like 1, 4, something, let me just give it some random 10 values, right? I can do for auto I colon A, and this will go through the elements of the array as well. So you can see that, okay, I only gave it 9 elements. So the last element got, the value of 0 automatically assigned to it. But yeah, so you can see that all the values are printed like this, right? So there are 10 values printed. So yeah, this is how arrays also go. So in vectors, you can do pushback, and one second, as I showed before, it adds a value at the end. Okay, I did not have to output the first one. Yeah, so you can see that it adds a 11 at the end. And now there are how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 values in total, right? Disable the public chat? No, I'll not be doing that. Why would I disable the public chat? The next thing is we can also pop back, right? Let's say I add a few too many elements, right? I added a value on accident like 142. Now, how do I remove it? So if I run this, this will output 11 and 142, but I'll not run it for a second. What I'll do is I'll output this again. And before I output it again, I will do v dot pop back, right? So I'll push back two values. I'll output the vector, pop back, and output the vector again. Let's see what happens, right? And obviously, I need to output an endl after this. If I run this. Okay, there you go. So you can see that first 142 is included, and then when I do pop back, it gets rid of the last value, and 142 is removed. Okay, let me just go to the comments quickly. Give me 1 second. Okay. Is there any, in terms of functionality, is there any difference? No, not exactly, Jayesh. So auto I colon V is fine. Going through the indices is also fine. Application wise, they have no different, like no particular better way to do this, I guess. Like in case of sets, right? Like you did ask what about other containers. Basically, if you're doing it for sets, the same looping method that you say is going to have to include iterators. So you'd have to do, I'll just briefly show you guys. I won't explain this, but I'll just briefly show you what it will, it will be horrendous. That's the point, right? We'll take for auto it equal to v dot begin, for example, it not equal to v dot end, for example, and then you'll take it plus plus or plus plus it. Doesn't really matter, right? You'll take something like this, and then each time you output it, you'd have to output star it. This will certainly have to happen for sets, right? You can do it this way as well, but this is way too complicated. This is what will happen if I print name of vector. That will be an error. Shubham says, but I guess index method can be used to change the element on that index. There is like, I mean, you mean like there is no index method. You mean the get operator, right? There's no indexing concept in set. Yes, that is correct, Snehashish. There's no indexing concept in set. Manoj says, what if we use combination of vectors and pairs? That's a very good question. We can, in fact, totally do that. We can take pair int comma int. And so v of 10, I'll just, right? So I can take v of pair int int. And now I can't push back 11 and 142, right? That is not allowed. And you can see that if I go through the vector, I'm not allowed to output I. The reason being, I will be a pair and pairs cannot be outputted directly, right? So, but I can output like I dot first and I dot second separately. That's fine. So I can output I dot first and I can output I dot second. This is completely fine, right? Okay. Dilshad says, but I can name of array I can print. Yes, name of arrays you can print, but for vectors that doesn't make sense. Like it doesn't exist for vectors. Okay, so if I run this, let's see what happens. Nothing happens because I don't have any values. Give me a second. I'll say this vector is equal to some pairs, right? Like I'll take 1, 2, I'll take 3, 5, I'll take 2, 9, and let's say I take 4, 4. Right, these are just some 4 pairs that I just randomly came up with. If I run this, you can see that I can output I dot first and I dot second like this, right? This works completely fine. Now, one cool thing, by the way, is that actually you don't have to go through I dot first and I dot second like this. One cool thing is that you can use something called structured bindings. In C++, there's something called a structured binding, which was introduced in C++ 17. So you cannot use this below C++ 17. You can only use this in C++ 17 and above. But what you do is you put square brackets, you take auto, square brackets, A comma B, or basically first comma second, something like this, right? Anything that you want, but I'll take A comma B. And now you can directly output A and B. It'll automatically take A to be the first value and B to be the second value. So if I run this, you can see that this will actually output 1, 2, 3, 5, 2, 9, and 4, 4, right? And it automatically does it. It takes A as the first value and B as the second value, right? So this is one very useful thing in C++. It's structured bindings. Destructuring. Maybe, yeah. Okay, that is fair enough. But yeah, this A comma B is structured in a way, so that would make sense, hopefully. But yeah, I do get your point. Right. Okay. So those are vectors, and honestly, there's not much else to discuss about vectors. They do have a lot of features, as I said, like you can do pushback, popback. And okay, one person asked how to insert a value. And to insert a value, let me just quickly explain. You can do v.insert, right? You can do v.insert, and you need to give it 2 values. The first value is the iterator. So let's say you take v.begin, and you give it the value next, right? One second. What is this? Oh, okay. Oh, this is a pair. I'm stupid. This I need integer. So let's say I take 1, 2, 3, 4. Now, basically you insert it by giving it an iterator. So you give it an iterator like v.begin and you give it a value like 5, right? And let me just say for auto A colon V output A. So I just want to output all the values of the vector. So if I do insert like this, right? If I do insert v.begin comma 5, at the first position, it will insert 5 and everything after it will be pushed by one step. If I run this, you can see that I get 5, 1, 2, 3, 4. Right. So I'll insert a value and then I'll push the rest to the side. And you can take v dot begin plus 2 in order to go to the, third iterator to be exact. V dot begin would be 1, v dot begin plus 1 would be 2, v dot begin plus 2 would be 3. Right. So this should be 1, 2, 5, 3, 4. So if I run this, it should output 1, 2, 5, 3, 4. Let's make sure of that. And yeah, there you go. It's 1, 2, 5, 3, 4 as we expected. Okay, cool. Does it make sense to everyone so far? Is this clear? Okay, Rajni says we can use set dot lower bound. Yes, Rajni, that will be discussed when we discuss sets. We have not discussed sets yet. So we'll be discussing that. I do have slides literally for binary search, so don't worry. Okay, cool. Perfect. Now then, vectors are done, right? Vectors are done. They have some features like insert, erase. Erase I'll not discuss. You can try Googling that on your own. If I discuss everything, I can keep going on and on for like the next 10 hours. So I won't do that. But yeah. Okay, cool. Now, the next thing that we're going to be discussing are sets. So we are going to be discussing sets. And well, we have looked at vectors and we know that vectors are an ordered collection of data, right? Well, technically sets are also ordered, albeit in a bit different way. Sets are also ordered in a different way, by which what I mean is they are sorted. So in vectors, if you insert 1, 3, 5, and then you insert 2, 3, 4, and then you insert -1, 10, it will be in the exact same order, right? So however you insert it, that's the way it will stay. It will stay the way you put it. But in a set, when you add a value, it actually automatically sorts the values. So that's an important difference, right? So it automatically sorts the values. So if you have 1, 2, 3, 4, 5, and you insert 0, then it will put 0 at the beginning. Right, we'll go over this. We'll go over this in just a second. But yeah, it stores sorted values. And another important thing is that it stores unique values, which is quite important because that's one of the most common applications of a set. Right. Now, what I mean is if I had a vector, we'd have like 1, 3, 2, 5, -1, let's say, something like this. And when you add the values, what will happen is we'll get -1 in a set. This is a vector. And in a set, what will happen is we'll have -1, 1, 2, 3, and 5. This will be the values in the set. For the very first time, syntaxes are confusing and hard to remember. I absolutely agree, Shubham. Syntaxes are certainly hard to remember. And if you have any questions so far in whatever we have discussed, if you have any questions, do let me know, by the way. But yeah, I will explain the concept of a set. But you have to use it in order to learn it, I'll be honest. Okay, so as I was saying, sets are sorted and they are unique, right? And what that means is, basically, let me go back here. We'll have, let us say, another 1 in this vector. What will happen is in a set, when there's another 1, it simply gets erased. And you just have nothing. And let's say you insert another 1 and another 2 and 5, right, in a vector. It'll all stay like this. But in a set, nothing will change because all the values are already present, right? 1 is already present. This 1 is also already present. This 2 is already present. This 5 is already present, and so on, right? So sets only store the unique values, right? Sets only store the unique values and they are sorted. Okay, Jay says, so if I ever want to sort any list, just pass it to a set and job done, or am I missing something? Yes, that's correct. You can pass, if you want to sort any list, you can pass it to a set. I'll show you that in just a second, right? But one thing is it will get rid of the duplicates. Keep that in mind. And you can just use a sort function, right, Jayesh? So in case you want to use the sort function, you feel free to do that. You can also insert it into a set though. That's completely up to you. Okay, so we'll have set int s, right? And let us say this is equal to the values such as 1, 4, 2, 3, -1. And let me just add a 1 in the middle here, 4 at the beginning here, and let's say I have 100, right? And now I can say for auto I colon s, which is again the same as we did for vectors, I can output I, and I can output an enter. right? I cannot put an enter. If I run this, you can see that all the values are sorted, right? All the values are now currently sorted. And you can also see that the unique values stay while the duplicates get removed. So 1 stays, this one gets removed, -1 is here, 4, 4, there since there are 2, one of them get removed, and so on, right? So only the unique values stay. All the other values are deleted. Okay. Now, one thing is, if you want to insert or remove or search for a value, well, what that means is that you will be taking logarithmic time, which is O of log n, right? And to be specific, this is log n base 2. But in generally in competitive programming for time complexity, we only use log. We don't say the base. So it doesn't matter if it's log 10 or log 2 or log 10,000, right? All that matters is that it's a log factor, right? So this can be done in logarithmic time. And the reason it takes logarithmic time is that set has to maintain a sorted order, right? So when you add a value here, when you add a value, it has to insert the value in the right spot, and that takes log n time. So it takes log n time to insert a value. But guess what? For vectors, it only takes O of 1 time. O of 1 time instead it's instantaneous. So if I want to add a value to the end, like if I want to add a value at the very end, only at the end, it will immediately add the value, right? And that will be O of 1. That's it. Is arbitrary implemented in set? Yes, that is correct, Snehashish. That is correct. The underlying implementation of a set is red-black trees. I will not be discussing. I'll absolutely not be discussing that though. It's way out of scope for this class. Okay, Manoj says, so wait, this set and hash set are both different. Yes, this set and hash set is different. I am guessing that you are coming from Java, but hash set is similar to unordered set, which we will discuss in a second. So it's similar to unordered set. And I'm pretty sure normal set is similar to tree set. There's tree set in Java, right, Manoj? I'm not a Java expert, so I'm not very sure. But yeah, tree set is the sorted set in Java, I'm pretty sure. And that is equivalent to set in C++. Normal set in C++. Okay. Now, one final thing is that for sets to work for some data type, the data type must have the lesser than function implemented. So for most cases, this is true. For most cases, like if you take 1 and 2, right, this is in defined. Integer and integer, it is defined. Right, so that's completely okay. How is set different from unordered set? We'll come to that. So integer and integer is completely fine. String and string is completely fine. And basically almost everything is completely fine for this. But there might be some exceptions, right? There might be some exceptions, in which case, if you're getting some issue like you cannot compare these two values, then that means that set cannot store them effectively because it doesn't know how to store it. It doesn't know how to like order the values, right? So if you have the lesser than function implemented, will the set know, okay, currently I'm supposed to, you know, check whether this is lesser or greater, and this is how I am supposed to sort, right? So that's how set figures it out, right? So it is very important that you just, in case you get an error using a set, just make sure that the lesser than is implemented for whatever data type that you're using, because integer is not the only thing that you'll use. You'll use a lot of different things, right? In the future, when you're solving problems or whatever, you will certainly use a lot of different things. In which case, lesser than function is absolutely important. Okay. Now, the next thing that we are going to be discussing are maps. Maps store a unique, basically unique key, right? Instead of value, it stores a unique key. Now, that's also sorted on the key, on basis of the key. So these unique keys are sorted in sorted order, and the value can be whatever you want, right? The value can be whatever you want. And again, search, removal, and insertion of elements are done in logarithmic time. Now, I know explaining maps with words is a bit hard, so I'll take some examples for it. So for maps, you have two different things. For a map, you have two data types, namely the key data type and the value data type, right? So you can have something like string int. Again, it doesn't really matter. You can have string. As long as the first value is comparable, it doesn't matter. The second value can be whatever you want, right? And someone asked, is set of sets possible? Yes, it is in fact possible. There you go. So sets of set word. Okay. Give me a second. Yeah, let's say I have a map of int to string, right? And I'll call this MP, and MP will be my map. Now, basically, you can say MP of 3, for example, equal to the string ABC. And you can say MP of 100,000, right? Something like 100,000 is equal to some random string. You can do whatever you want with this map, right? You can put whatever key that you want for the first value, and the second value, it does not matter what it is. It can be absolutely anything. The second value can be anything. The first value has to be sortable. So similar to sets, the first value, which is the key, has to be comparable, right? Just keep that in mind. The key also has to be comparable. And one thing that you might have noticed is that maps are actually similar to vectors. So for example, here I can take MP of 3 equal to ABC, and later I can see out MP of 3, right? This is similar to a vector, right? Now, Sneha says, can map size exceed 27? Probably not. That's not possible. Depends on how much memory you have, but it's likely not possible. Jay says, following upon the question of set uh, question, how are the nested sets sorted? Again, dictionary order? Yes, exactly. When in doubt, just use dictionary order. That's how C++ operates. Okay, mine says I use structured bindings in maps in C++, but it shows error. That should not be showing an error. Can you like check once that you have done it properly, Mayank? What is TC for looking for an element in a map? It is O of login. Searching, insertion, deletion. All of them are O of login. Now, one thing about this is that, as I said, maps are pretty similar to vectors, except that they can have any value, sortable value. I'll just add this here. Any sortable value as the index. So as an index, you can literally have any sortable value. Integer, yeah, fine. String, yeah, fine. Vectors, yeah, fine. Vectors are also sortable, right? And so on. So for example, I can take a map of, ABC equal to, let's say, ABC. I just have, I'm not very creative, as you can probably tell. But yeah, so I'll say map of ABC equal to ABC, and I'll say map of like some random string equal to another random string, right? So I can do something like that. Cannot search an element in map in often. No Snehashish, that's not possible. I'll come to how you can do that using an unordered map in a second. But with normal maps, no, that is not possible, unfortunately. Okay. Now, what I can do to go through the map is first of all, to output a value, I'll just take map of ABC. This is pretty easy to output. And you can see that again, this index is any value, right? So you can think about this key like an index, and this index can be absolutely anything. Now, to go through a map, right? So to go through a map, there is one thing that you need to realize. Maps store values in pairs, right? If you give it map string comma string, then the pair value is going to be pair of string comma string. This is very important, right? Pair of string comma string is how it goes. So if you store a value in a map, then the map is actually going to store the value using pairs, right? So what you can do is similar to a vector of pairs, you can take auto key comma value, auto key comma value colon MP. And you can see out key and you can see out value. And let's try running this. Okay, I think Zoom has some issue because every once in a while, like 5 people leave at the same time. Literally at the same time, 5 people leave. I don't know what is happening. And they join back a while later. I do not know what's going on. But yeah. So you can see that basically if I output MP of ABC, that's giving me ABC, which is, the value. And then for each key and value, it's outputting the key and it's outputting the value. Right. So this is how maps operate. Okay. So far is everything clear? Any doubts at all? I'll just wait for a minute. If anyone has any doubts so far, please do let me know. In case of any doubts, like literally anything. regarding the topic that we have discussed? Okay, you know what? We'll have a short break of, let's say, 5 minutes, during which you can ask me any doubts. Okay, Sham says if I don't use structure pair, then MPP dot first and MPP dot second. No, no, not MPP dot first. You can take like, if you take auto I colon MP, then you do I dot first. I guess by MPP, you mean the pair. I'm not sure what you meant by MPP, Sham. But basically, the idea is like this: you take auto I colon MP, you output I dot first and I dot second, something like that. Could you explain the searching part time complexity? So, for this, you have to actually dig a lot into the C++ code. But there is something called an arbitrary, which I will not explain, right? Which I will not be explaining. But there is something called an arbitrary. And to find a value in an arbitrary, it takes log n time base 2. Inserting a value, again, that takes log n time base 2. Removing a value, again, log n time base 2. Right. So all of these are log n time base 2. So that is the time complexity. And again, I do not want to explain this because arbitraries are not simple. They will take a lot of effort from my side and your side. Probably like 5-6 hours would be spent just discussing all the details of arbitraries. Okay, maximum element we can have in map. No, there's no maximum. As if the number is large enough, you can insert whatever you want. Shivam says, is there any problem while giving unordered map of pair as reference to some function? I didn't get you, Shivam. Unordered map of pair as a reference. The reference variable you mean? Like you are giving the map of pair. Let's say the unordered map of pair is XYZ, and you're giving XYZ as a reference variable to a function as a parameter. Okay, so it's a reference variable. That should not be an issue. No, that shouldn't be an issue. Abhishek says, is there anything in STL except BS, algo, sets, maps, vectors that is important for CP? There are many miscellaneous functions. There are also like DQ, stacks, queues. First of all, there's also priority queues. And maybe this is not exactly STL, but there is something called PPDS. A lot of different things are there in STL, right? And obviously the functions are endless. Like you have next permutation is sorted, there's normal sort, partial sums, accumulate. I could just keep on listing stuff. So yeah, like there are a lot of things, way too many to count. That's why we have to prioritize and learn the more important ones first. Okay, so at 7 o'clock we'll resume. Till then, if anyone wants to take a short break, feel free to take a short break. And if anyone has any doubts, feel free to ask me and I'll be answering them. We'll continue at 7 o'clock sharp.
Hello.
Yeah, go ahead, Vinod.
Sir, please could you explain vector again, sir? Just a recap.
Recap of vector. Yeah, sure. We can do a recap of vector. Give me a second. Yes, Abhishek, you are correct. Okay. So, vectors basically, if I have a vector, this vector can have any data type. I'll just give it an integer. And this is similar to arrays. Now you can do pushback, you can do pop back, which add and remove values respectively. And you can create the size of a vector by passing in the value like 1, 2, 3, for example. This will be 1, 2, 3 elements in the vector. If you add a value like 5, that will add it to the end. Pop back will remove it from the end. Those are vectors. And you can obviously use array indexing like pi equal to 3. So this will change the fifth index to the number 3. Okay, I'll take a look at your doubt very soon, Mayank. Don't worry. What's the duration of the session? So we are planning to go for around 45 more minutes, probably. Pop back or pop both exist? No, pop doesn't exist. Pop does not exist. Only pop back exists. Set recap, please. Okay, we'll do that in a second. Let me just answer Mayank's
Hello,
doubt.
am I audible?
Yeah, you are audible, Shubham.
Sir, I want to ask, like, are we allowed to use STL in the technical interviews?
Okay, that depends on the technical interview. If it's good, they'll allow it. If it's bad, they won't allow it. Okay, I'm kidding. But yeah, like for sets and vectors, like sets, vectors, maps, you have no other choice. You have to use them. In a technical interview, that will take, like, literally people have learned this stuff for decades to implement them, right? And I'm sure it will take you at least like one whole day to implement it. So yes, in the technical interview, normal STL like sets, maps, vectors will be allowed, but they might ask you for an efficient solution without using the STL. It might be possible that without using the map or set or whatever data structure that you want, you can still solve the problem. In which case they will say that, and in which case you will have to avoid using this STL. But otherwise, you have to. Like in case the problem needs you to use a set, you can't use any other alternative. So it's very important to know STL. What all topics are expected to be done till the end of the class? We are going to be going over unordered set, unordered map, and binary search on sets and maps, and normal things. Okay. Now, set recap, please. Okay, William, I'll be doing that. So basically, we have set int, right? So we have set of a data type, and we'll call it whatever we want. To insert a value in a set, you can do dot insert, you can do s dot insert, or you can do equal to like 1, 2, 3. You can do that as well. And to erase a value, I didn't discuss this actually, but to erase a value, you can also do like this. Set s dot erase 3 will get rid of 3 if it exists. And yeah, the set will be sorted. It will get rid of duplicates. Can you explain how to use map of maps? Map of maps are almost never used, I'll be honest. There's a bit of background noise. I'm really sorry. Like there is some mosquito repellent thing going on outside, which is pretty sad timing, but yeah. Sham says during STL implementation many times I have come across questions in which I have to put array element in maps, how to put element of different container in other containers. Syntax becomes confusing many times. Okay, I'll come to that in a second, Sham, because that's an interesting question. Okay, Jay says, how do you prepare for a situation where they ask you to avoid using C++ STL? Honestly, I don't know. Just practice lead code. Literally, just practice lead code because they have enough of those stupid problems where you have to optimize something unnecessarily. So yeah, so yeah, that's the honestly the only way you can practice for that. Okay, cool. We'll continue. Just give me 1 second. Snehashish, please ask general questions at the end. Mayank, I will go through your. Wait, what? What's your doubt again? You asked. Oh, okay. How to search based upon the values of maps. And my second doubt, how to sort based upon uh maps if I have to use custom comparator. Okay. So my custom comparators won't be discussed in this class. So again, I'll answer this at the end because this will be a bit long. So I don't want to waste everyone's time. So please ask this to me at the end. I will discuss this briefly. Second, you cannot sort based on values of maps. That's just impossible. It's impossible to sort based on the second value. Okay. Now, yeah, I guess we can continue now. My God, why is there a lot of noise outside? Okay. I really do not know how to fix this issue, but yeah. Okay, cool. I hope the noise is not very distracting. Can everyone hear it? Oh, okay, cool then. Apparently Zoom's noise cancellation is very good. Okay, cool. So Sham actually asked during STL implementation, I have come across questions in which I have to put array element in maps, right? Array element in maps. So what that basically means is, like I guess this is what it means. Like you take a map of vectors, maybe. Do you mean something like this, Sham? Can you give me a short example? Okay, so if there's a question like this, then I'm pretty sure there's not a question like this, Sham. Like generally, this is not common at all, right? This is not common at all. And if there is a question like this, I'm pretty sure it will be based on like something else. I don't think this is present in anything, honestly. But we take it in values, not keys. Oh, okay. So you take int, comma, vector int. Okay. Now that makes more sense. So in case of something like this, first of all, realize that, so this is just a general thing for everyone. Realize that again, this map is just like a vector, similar to a vector, right? So what you can say is map of phi or something like that, for example, is nothing but a vector, right? If you take a map of phi or something like that, it's a vector. Now, if I take map of phi dot, right, dot pushback, this map of phi, this is a vector, and to that vector, you're doing pushback of a value, like 6, right? So you take map of phi, which is a vector, and in that vector, you're doing pushback, right? Similar if it was a set. If it was a set, you will do map of phi dot insert 6, for example, right? If you do dot insert 6, that will insert 6 to the map, right? Okay. Yeah. Okay. Okay, cool. Rajesh has said, check the sort map by value article. No, I'm pretty sure it's basically just, swapping values and keys. But yeah, generally that's not a very good idea because, see, the values are not duplicate. Like values can be duplicates, right? So what I mean is, if you have a map intent, make sure that whatever you're doing is very like correct because sometimes it might not be. So if you take, for example, empty of 5 equal to 3, you can also do empty of 7 equal to 3, right? So multiple map inputs can point to the same value, right? So multiple inputs can lead to the same value. Okay. He meant like duplicating a set to an array or vector. But we take it in, okay, wait, what? Many to one function. Yeah, that is true, Jayesh. Yeah. Okay, okay. Abhishek says, is there something like multi-maps, like multi-sets? Yes, there is a multi-map, Abhishek. There is a multi-map. And it's not very used, I guess. Multi-maps are quite useless, but it is there, in case you wanted. Okay, fine. Okay, just give me one second. I'll just investigate this sound and then I'll come back. Okay, fine. Yeah, I'm back. Okay. No, no, Jayesh, I understand. There's nothing from your unordered set. So no, the what we are going to be looking at is this. Is the voice breaking for me only? Yeah, it's probably breaking again because of the sound. Like noise cancellation is not perfect. Okay. Now, basically, okay, it's finally gone. So unordered sets basically store unique values as well. It's very similar to set. Unordered sets are very similar to sets, except that they store it in a random order. They also store unique values, except in a random order. It is just not sorted, right? So sets store unique values in a sorted order. Unordered sets, like just like the name suggests, but in for the for the cost of sortedness, let's say, they are faster. They are far, far faster, right? And I hope my voice is better now, by the way. But yeah, so they're far faster, as in they are O of 1. So big O of 1 basically means that the time complexity is constant, right? Okay, Abhishek says it's inserted in the way we insert them. No, that's not correct at all, Abhishek. You can test it out. I'll actually show you in a while. But yeah, that is not true at all. They are very random. Okay. Now, again, as I said, it takes constant time. And constant time, what that means is that it, no matter which value you insert, no matter how many values there are, it doesn't care. It takes the same amount of time every single time, right? So unordered maps are just faster in that way. And yeah, they're quite useful, right? They are quite useful because they are faster. Sorry, I'm at maps right now. I should discuss sets first. Yeah. So again, they are pretty similar though, to be fair. Yeah. Okay, but one small thing, this time for unordered sets, it is actually not possible to store pairs, because for unordered sets to work for some data type, the data type must have a hash function implemented. So a hash function is something that basically, like I won't again go into too much detail, because again, this is an overview. I won't go into too much detail into anything almost. But yeah, basically of a value, hash of value takes in that value, and all that it does is it provides a new output, new unique value. Now, the one thing about this new unique value is that it might not be unique actually, but again, that comes under the details of hashing. But yeah, if you take a value, it compresses it and it converts into a new unique value that is compressed. That is compressed. Right. This is the general idea. General idea behind hashing. Right. Now, basically, pairs cannot be hashed. Vectors cannot be hashed. And many other data types actually cannot be hashed. But fortunately for us, integers, strings, and other like common stuff like chars, all of them, they're all possible to be hashed, right? So you can hash all those in for primary data types basically, but everything else is not possible to hash. Okay, now let me just read the questions. Striver says it takes open search time in some cases. Yes, I will come to that, Shubham. Abhishek says, can you repeat hashing one more time? Yeah. So basically, hashing is taking in a value, maybe a big value. This is a big value, and it compresses into a small value, unique value that is small as well. Not necessarily always, but it does happen. It does sometimes. Two values can have the same hash, because if you compress a lot of values into a smaller domain, right, then obviously there will be some clashes. But it tries to minimize that. It does its best, but sometimes it's just not possible. Few examples for hashing. Um, I mean, one hash could be if you have ABC, right? Let's say you have ABC, then it's a terrible hash function. I'll tell you why. But you can hash ABC like this. You can say that, okay, what's the index of A? It is 1. Index of B, 2. Index of C, 3. Then the hash of this is 1 plus 2 plus 3 equal to 6. This is a terrible hashing method because you can have a lot of, equal hashing. For example, if you take CC, that will also be equal to 6, which is not unique, right? So yeah, this is a hash function, for example. Now, the reason this hash function exists is because C++ wants to store the data in a unique values such that, they can be compressed, right? They need to be compressed, otherwise it will just take too much time, right? So it compresses it and then it puts it in its, I don't know, like it just stores it somewhere and then it accesses the value, right? So that's basically how it goes. And again, someone asked, okay, one second. Stiver says that it takes O of n. Yes, that is correct. One thing about unordered stuff is that on paper it is O of 1, right? But this is something called amortized. Amortized. What that means is in the average case, right? In the average case, over a lot of computations, this is O of 1 per computation. O of 1 per computation over a lot of computations, right? But let us quickly think about how this is exactly hashed, right? So when a value gets hashed, what happens? Well, we know that it becomes a value, right? Like if I take a hash of a value, then what happens is you get a unique number. So you get a unique number n, let's say, right? Now you can give another hash for this, and let's say you give another value in a particular way such that this hash also has, the same n, right? And you give it another value that has the same n and so on, right? The issue here is that let's say there's another value. If you pick out perfect values for this hash function such that it's always n, right? Then what will happen is something called a collision. As I said, like collisions is when multiple values have the same hash. Now, when you try to find unordered set. Let's say I'll just call it US of some value, then this will have to go through literally all the values here, right? So this will have to go through every single value in order to figure out which one is equal, right? Because all of them have the hash, same hash, right? When you take unordered set of value, then that value actually gets hashed and it checks unordered set of n actually. Like it checks the number n, it looks at, okay, what are the values that are there for n, right? And turns out all the values are there for n, right? Like we gave a particular input such that all values become n, right? All values, literally all values become n, which is pretty bad, right? So this takes a ton of time, which to be exact is O of n, where n is the number of elements. Number of elements. Right. Now, I know that might have been a bit weird, but basically think about it like this. You have an array which says that, okay, if I get a number 3, if I get a value, hash value of 3, I'll add whatever gave me a hash value of 3 to this array, right? So let's say that XYZ gave me a hash value of 3. So then I'll put XYZ here. Now let us say that AB gave me a value of 3. Then I'll put AB over here, right? And all the values that give me 3 will be added to this particular list, right? Now, the issue is that if everything had a value of 3, then all of them will be 3, right? And when you look for 3, then what will happen is it will have to go through every single value in order to figure out which one it is actually equal to, right? And that takes a ton of time. And that unfortunately takes a ton of time, which is, to be specific, O of n. Will this video be posted on TLE YouTube channel? Yes, Manoj, it will be posted. Okay, cool. I hope that made sense. Is that clear to everyone? Any doubts here? Did that make sense? Please let me know in the chat with the +1 if this is clear. Okay, cool. So, yeah, I guess we can move on then, right? Now, unordered maps are pretty similar. I won't go through unordered maps again because again, they are literally the same as maps, except that the keys are stored in random order, right? And similarly, again, the data types must have a hash function implemented, and that's all, right? And to use them, all you type is literally unordered map. Like you just type unordered underscore map, and everything else is the same. It's just in a random order. I'll just show you how an unordered set looks, right? So if you put in some values, let's say you insert 5 and you insert some random values like 4, 7, and 10, you might find a pattern. You might find a pattern for small values like this. And I'll take for auto I colon S, C out I. Right. If I run this, you might find a particular pattern. We can't use set and vector in map, unordered map. Yes, we can't use that. So you can see that this is sorted in reverse, but this is not always true. If I insert far more values, right? So if I take S equal to, okay, actually this is inserted in reverse order, right? Like 10 is first, 7 is next, 4 is next, 5 is next. But that's not always true at all. Like if I take 1, some like random order, and let me take some big values because why not? And if I run this, let's see. Yep, you can see that it's not necessarily in reverse, right? 1 is at the beginning over here. It's over here. We have 1, 3, 16. We have 1, 3, 16. Then we have 5. Then we have 6. Then we have 2. And then we have 13, 10, 100, and like the largest value. So you can see that there is no particular order to this. Like it's just, you might see a pattern because, unordered set does follow some particular ways to figure out the hash. But if you take a large enough set, it will be random. It will be mostly random. You won't be able to predict a pattern, right? So just keep that in mind. There's no particular pattern to an unordered set. Even if for small values, it appears like there's a pattern. Okay, cool. So yeah, those are unordered sets and unordered maps. If anyone has any other doubts regarding this and I missed it, please do let me know, by the way. So we do use unordered set. Why? So we use unordered sets because again, in some cases this is faster, right? In a lot of cases, it's theoretically supposed to be faster. It's supposed to be O of 1, right? One recommendation: do not use for CF. Do not use for code forces, right? Do not use this for code forces. I will share a blog which will allow you to use this as long as you read the blog properly and copy the stuff that's in the blog properly. You will be able to use this. But till then, do not use for code forces. You can stick with maps or sets. Normal maps and normal sets work great. Okay, trust me, they work great. They are not that much slower. Like even if it's login, which is theoretically a lot slower, it's actually not even that much slower, right? So just keep that in mind. Maps and sets are actually very fast too. Why so? Because for the largest input that you can get, which is like, let's say 10 to the power of 6, right? 10 to the power of 6 could be the largest size of the array, right? Now for 10 to the power of 6, log of this is actually approximately equal to like 20. That's all. It's only equal to 20. So yeah, this is not slow at all. This is only 20 operations. And unordered set, even though it claims to be O of 1, might also be like O of 10, right? Because O of 10 gets changed into O of 1. And this is very variable, right? And in the worst case, this is like O of, this is like O of like, N. In the worst case scenario, on average, it's O of N. But yeah, how did you find that log of 1e6? Shubham, I just have a lot of experience. I've seen so many different logs that I basically have memorized them. And I'm obviously talking about base 2 here. Or one more thing that you can do is take 6 into log 10 base 2, which is, also equal to like approximately 20, but yeah. Or using Excalibur with Obsidian with Excalibur extension. Yes, Bhave, that's exactly right. I'm using Obsidian with Excalibur extension. That's perfectly right. Okay, cool. Now, yeah, what were you talking about? Yes, log. So log, as you can see, is not that much slower because again, unordered maps and unordered sets could be much slower. And in code forces, the issue is that other people can set your test cases. And other people, if they see you use an unordered map, they will make sure to find a test case such that your code fails. Right. Just keep that in mind. They will find a test case such that your code fails. And they will make your rating, decrease. Yes. Yeah. So just saying, do not use that. Right. So avoid using that for code forces until I share that blog. You can read that blog. But in case you haven't read it before, or in case you are going to like use unordered map without reading the blog, just don't. Just use the normal map or set. Okay, cool. So that should be fine. I don't think there's much more to discuss regarding that. Why they bad like this? Because they hate you and they want to increase their own rating as well. Okay, now the next thing that we are going to discuss is binary search. Right. Now, binary search, well, there, you can learn it yourself. Obviously, you can implement it yourself. But, for lazy people like me and you, basically what we can do is we can just simply say that use the inbuilt binary search. Right. We can just use the inbuilt binary search. And what we can do is just call that. Literally, that's all. So what you can do is important for OA and CP. Yeah, you mean inbuilt. Inbuilt should not be used for OAs, I'll be honest. Like for online assessments or whatever, do not use the inbuilt binary searches because again, the interviewers will expect you to know binary search and they will expect you to implement it yourself. Okay, so let us say that we have a vector is equal to 1, 2, 3, 6, 5, okay, 5, 6, 9, and 10. Right. So this is our vector here. And we want to check if the number 4 exists and we want to check if the number 5 exists. All you have to do is see out a dot, no, sorry, not a dot, binary search a dot begin to a dot end. Right. And you give it the value that you want to look for. So if you give it binary search a dot begin to a dot end and you give it the number 5, then it will tell you whether it exists or not. This is only true or false. Keep in mind, this is only true or false. Now again, let's do this for 4 and let's run this. So for 4, it should be false, and for 5, it should be true. So as you can see, yeah, exactly. For 4, it is false, which means 0. And false is generally written as 0 in C++, and true is written as 1. Right. So yeah. So this is 4 is false and 5 is true. So this is all that binary search does. It tells you whether the value exists or not. So this is not that interesting, so I'll move on. The next thing that we have is called lower bound, right? Lower bound is a function that returns an iterator. So keep in mind, this returns an iterator of the first element greater or equal to the given target. So let me just write this. Lower bound, which I'll shorten as LB, will be the first element, first value, C++, but they decided that upper bound should be the first value greater than target. So lower basically means that it's greater than or equal to, and upper basically means that it's greater. First value greater or equal to target, or first value greater than target. This is literally it. Right. So lower bound is greater or equal to, upper bound is greater than. Just keep that in mind. And again, I do not know who named it this way. And so again, I do not want to try and explain it. But one thing is that both of these return an iterator. Both of these return an iterator, which means that it gives you the value itself. It doesn't tell you true or false. It gives you the value itself. And what that means is if you do lower bound, a dot begin to a dot end for 4, right? What this should give you is the first value greater than or equal to target, right? Now, this is an iterator, and to convert that iterator to a value, you take a star at the beginning. So you take a star at the beginning of an iterator in order to convert that to the value, right? Now, we are expecting this to give us 5. And let's see if that's correct. And let's also give it lower bound for 5, right? So lower bound for 4 should be 5, and for 5, it should also be 5. And there you go. That's exactly what we get. Right. Now let's try another value. Let's say I take 6 and 7. That should, for 6, I should get 6, and for 7, I should get 9. And that's exactly what we get. Right. We get 6, and for 7, we get 9. Now, let me try taking the upper bound. Let's try taking the upper bound. And let's again start with 4, 5. So for 4, I'm still expecting 4. For 4, I'm still expecting 5. But for 5, you can see that this actually takes a greater value, right? Which is 6. So greater than 4 is 5, and greater than 5 is 6. And it's exactly what I output, right? So for 4, I output 5, and for 5, I output 6. Okay. Abhishek says, can we use lower bound address of first index for finding index of the elements present? Of first index, lower bound minus, minus, that's a minus. Yes, you can in fact do that. That's exactly right. I was going to discuss that right now. Basically, to get the index, right, all you have to do is subtract the beginning index. You have to subtract a dot begin. Now, let me explain how this works. So we know that if you take a dot begin plus I, that will be equal to ith iterator. Right. Now let us say that you are given the ith iterator and a dot begin. Then what is I? Right. Well, all you have to do is rearrange the equation, and you get ith iterator minus a dot begin is equal to I. So if you have the iterator, and you subtract a dot begin, you will get the index I. That's basically what this is saying. Right. Now, okay, one thing that I do want to clarify is that this is binary search. This is still binary search, right? So what that means is that the array should be sorted. Just keep that in mind. Sorted array is necessary for this, right? Okay. Now, let's see. Okay, cool. It's the same as we do si minus a. Oh, yeah, actually, that's exactly right. If you take a character c and you take minus a, that will be equal to the number 2, right? If you take a minus a, that will be equal to 0. B minus a would be equal to 1. And c minus a will be equal to 2 and so on, right? And similarly, if you take the number 9, let's say minus 0, then the character 0, that will be equal to 9. And if you take the integer 9, that's the difference, right? And if you take 4, character 4 minus character 0, that will be equal to the number 4, integer 4, right? It's wrong to use UBLB during online assessments. It will save more time. So you can clarify this. Online assessments, absolutely use whatever you can, right? Online assessment, your goal is to solve the problem. But during an interview, make sure to confirm it with the interviewer. Ask the interviewer, can we use this, right? And if he says no, then you have to write it manually. If he says yes, that's allowed, then you can, feel free to use it. So yeah, during an interview, don't risk it. But during a online assessment, always use the best tool at your disposal. Okay, so yeah, so upper bound takes a dot begin to a dot end, and if I subtract it, it also will give me the index. So let's make sure of that. So it says 5, 6, 3, 4. And the index of 5 is in fact 3, 0, 1, 2, 3, right? And the index of 6 is in fact 4. So yeah, there you go. So if you do upper bound and if you do subtract from the iterator, that also gives you the index. So upper bound minus a dot begin gives you the index, right? Okay, cool. Yeah, so that is basically binary search upper bound and lower bound. So it returns the iterator of the first element greater than or equal to the given target. Okay, now one thing that I will shortly discuss, I won't go into too much detail into this, but since we have time, we might as well discuss this. But basically, if you take the iterator, let's say I say auto IT equal to upper bound, a dot begin to a dot end for the number, let's say 11, right? This doesn't exist. So first of all, this will be equal to a dot end. IT will be equal to a dot end if it doesn't exist. If value doesn't, I mean, not there exists, my bad. If the value is too large. If the value is too large, this will be equal to, a dot end, right? This will be outside the array. And I hope everyone knows that a dot begin points to the first value. A dot begin points to the first value, while a dot end actually points to the index after the last value. So if you have a dot end minus 1, that will be equal to the iterator of 10. But if you take a dot end, that is actually outside the array. If you take a dot end, that's outside the vector over here. And so you cannot access the value. There is no star a dot end. This will actually be an error. If you take star a dot end, that will be an error. So yeah, just keep that in mind. So if the iterator is equal to a dot end, that means that the value was too large. It doesn't exist in the array and it is too large, right? Now, one thing to keep in mind is, see, if we take lower bound, we know that it's greater than or equal to, right? We discussed this. Lower bound is greater than or equal to. Now, what will happen if I take lower bound minus minus? So there is one thing that we can do to iterators, which is subtract 1 from that iterator, right? We can subtract 1 from any iterator. So if I take a value like 5 and I subtract 1, then what this will do is actually this will be equal to last value lesser than the target, right? If you take up lower bound minus minus, then it will be the last value lesser than target, right? So the first value greater than or equal to target. What is the previous value? That was the last value lesser than the target, right? Does it make sense? Since this is sorted, we have two sections like this, right? In this section, we are saying that this is the first value greater than or equal to the target. Then the previous value has to be the last value less than or equal to the target, right? Does it make sense to everyone here? Please let me know in the chat if this is clear. Repeat this LB minus minus portion. Yeah, sure. So first of all, LB minus minus decreases the iterator index, right? Now, let us say that we have something like 1, 2, 3, and 5, 8, 9. Now, if I do lower bound for 5, if I do lower bound for 5, that will give me the iterator for 5, right? That will give me the equal value. Now, if I take this lower bound value minus minus, then what will happen? I'll move to 3. And guess what? 3 is the last value lesser than 5, right? 3 is the last value lesser than 5. Now, let us say that I did a lower bound for, let's say instead of 5, I did a lower bound for 7. That will go to 8, right? Lower bound for 7 will point at 8. Now, if I take the lower bound for 7 minus minus, then that will go to 5. And again, 5 is the last value that is lesser than 7, the target, right? Now, if I take this, you can see that LB minus minus will be the last value that is lesser than the target. Now, similarly, if I take upper bound minus minus, it will be the last value. Okay, let's see if there's a guess in the chat. Can someone try to guess? What will it be? Any guesses? Equal to. Equal. Not necessarily. Does upper bound always mean that the previous value will be equal? Equal or less. Exactly, Abhishek. That's exactly right. It will be less than or equal to, right? So let us say that I'm doing upper bound for 7. That will still point to 8. So if you do upper bound for 7, that will point to 8. If you do minus minus, that will point to 5. So that's the first value less than last value less than or equal to target, right? Yeah, like Anand and Abhishek said, it is less than or equal to, not just lesser than or equal to. It's less than or equal to. Right. I highly encourage everyone to experiment a bit with this. I won't go through this too deeply, but I did see a question regarding this. I'll just read that for a second. I don't think we can do this operation on auto node equal to lower bound node minus minus. You can though. You can do that. Okay. One thing to be very careful about is never do this. Never do it like this. Now the reason is IT might be equal to A dot begin. And A dot begin minus minus, IT minus minus will be an error. Just keep that in mind. Yeah, exactly, Snehashish. That's a very good question. That's exactly what I discussed right now. You cannot do this, right? It is not possible. If you have 1, 2, 3, 4, 5, let's say you had 1, 2, 3, 4, 5, and you did lower bound for 1, then that will point to 1, right? So if you did minus minus, that will be an error. So never do this. Never take minus minus like this. Always make sure that if IT is not equal to A dot begin, then you do IT minus minus. And otherwise, what that means is, else, that means that there is no lesser value or less than or equal to value depending on LB or UB. Right, upper bound or lower bound, depending on that, you take lesser than or less than or equal to. But yeah, there's no value that's lesser or less than or equal to the given target, right? So just keep that in mind. So for example, again, if you take 1, 2, 3, 4, 5, if you take 1, 2, 3, 4, 5, then if you take lower bound for 1 and you do minus minus, there is no lesser value, right? Lower bound minus minus is the first value that's, I keep saying first. It's the last value that's lesser than the target. And there's nothing lesser than the target. There's nothing lesser than 1. So that is an edge case. So make sure to handle that in this else statement. Never take IT minus minus directly because that will cause you issues. So just keep that in mind. But yeah, other than that, this should be fine. Okay, cool. I hope this is clear to everyone. And we finally have one last thing, which is binary search on sets or maps. Now, this is a special case because sets and maps actually have a different binary search. Please keep this in mind. This is very important. Never use the binary search over here, like upper bound and lower bound, for sets and maps. Okay, I will show you this. Let's say I convert this vector to a set. Upper bound still works, right? Now, if you use C-line or something, okay, please mute yourself, Zelensky. I'll mute you in myself, but yeah. Okay, so if you do upper bound, like if you do use C-line or something, If you use upper bound, then clang tidy, there's something called clang tidy that will tell you that you should replace it. But VS Code and stuff won't tell you, right? And the reason is because for sets, there is an inbuilt binary search. And that binary search simply goes like this. You just see out a dot upper bound. Fine. And you can take a star. Right. You can take star a dot upper bound 5. That's it. And you can use dot lower bound as well. Unfortunately, there's no dot binary search. But yeah, other than that, everything else is there. Right. And instead of dot binary search, if you are using C++ 20 or more, you can use dot contains, which tells whether value exists or not. So dot contains tells whether value is present or not. And if you use C++ 17 or lesser, you can use dot count, which will be 1 if it exists, 1 if exists, or 0 if not. And dot contains will be true if it exists and false if it doesn't exist. Right. So yeah, you can use dot count, dot contains. You can use that based on your like C++ version. But yeah, no. The reason you should never use upper bound like this is because it is actually going to be O of n. If you use the built-in upper bound for sets, that will be O of log n. And we know that binary search is O of log n, right? Binary search is O of log n. But if you use this upper bound, then that would be O of n. This is way too slow. Just keep that in mind. This is way too slow comparatively because see again for 10 to the power of 6, which is 1,0,0,0,0,0, you would approximately take only 20 operations. But if you do the above method, this will take 10 to the power of 6 operations, which is way slower, right? So never do this, never ever do this. Make sure that you're using the inbuilt upper bound or lower bound. Why is it O of n? Didn't understand. I'll explain that briefly in a second. But another thing which will be necessary to understand this is that actually in sets, you cannot take minus. You can't take minus a dot begin. This is just not a thing in set. In a set, you cannot get the index of a value. It's not possible. It's just impossible to get the index of a value. Right? It's impossible to get the index of a value, no of log n or whatever. So yeah, just keep that in mind. That's just a thing that you should, just make sure that you don't forget it, right? You cannot index a set. You cannot take a dot lower bound 5 minus a dot begin as well. That's just not possible, unfortunately, right? Okay. Now, Manoj says so many built-ins to take into consideration. Yes, that is true. But this all has a reason, right? All of this has a reason. As long as you understand the reason behind it, I'm sure that you will be able to remember it better. But I will explain the reason behind this one, right? The reason is lower bound on the outside, lower bound for a dot begin to a dot end, does not know how the set works. It does not know. I'll output star. This lower bound, external lower bound, I must write that, external lower bound does not know how this set works. Right? It does not know how the set stores the values. It does not know that, okay, the set, you can go, you can do this in order to binary search. You can do that in order to binary search. In fact, lower bound doesn't even know the values directly, right? It has to ask the set every single time for the values. Now, since this is not a random access iterator, and I know this is just a fancy way to say stuff, but basically it's just saying that you cannot index in a set. Since it cannot index in a set, when it wants the middle element, let's say it wants the fifth element, right? It has to take an O of n approach in order to get the fifth element. It has to take an O of n approach. Then what it has to do is it has to take an O of, like after O of n approach, it does binary search, right? As I said, it does binary search. So it takes the middle value and it loops for n by 2 times. Right? To get to the middle value, it has to loop for n by 2 times. Then it looks for the, it gets to do binary search. So now it looks on each of the halves, right? If you don't know binary search, don't worry about this. You don't have to know the explanation yet, but yeah. So let's say it is not on this side, it's on the right side. So it will take the middle value again and it will get rid of one of the sides, right? And that will be plus n by 4. In order to iterate again, that will be n by 4, right? And in order to iterate again, that will be n by 8 and so on. And it turns out if you keep adding this will just be equal to n at some point, right? So if you add up all of this, you will actually notice that this is just equal to n. And that is where the time complexity comes. That is basically where the time complexity of lower bound comes. External lower bound does not know how the set works. It does not know how the values are stored, how the values are indexed, etc. So it has to be slow. Unfortunately, it cannot be fast. But if you take a dot lower bound, that's the inbuilt into set. The set, it's a part of the set, right? This lower bound is coming directly from the set itself. And what that means is that this lower bound has all the information of the set, right? This has all the information of the set. And so, well, yes, there you go. It has all the information of the set and you can figure out stuff very fast, hence being O of log n. Okay. Does it make sense? Like if you use the external lower bound, it has to go through all the values. And if you use an internal lower bound, it knows all the values, so it will directly binary search. It knows the values, it knows how to iterate through the values, and so it can binary search pretty easily, right? So yeah, that is the reason why lower bound, unfortunately, outside will take O of n, but inside will take only O of log n. And again, this is like outside lower bound expects random access, which means that you can just randomly access any index. Inbuilt lower bound uses something called bidirectional iterators. What that means is you can do iterator plus plus and you can do iterator minus minus, right? And see, if you want to add this iterator by 5, if you want to take iterator plus 5, then you have to repeat this process 5 times, right? So if you want to get to an index n by 2, then you have to loop n by 2 times, obviously, right? So if you do iterator plus plus for n by 2 times, that's n by 2. So that's basically where the time complexity comes from. Phew. Okay, cool. Is that clear to everyone? Any doubts? Does anyone have any doubts at all in this part? I'll just wait for a few minutes. If anyone has any doubts, please do let me know. But yeah, that's actually basically the end of the session. Congrats, everyone. You made it to the end of the session. Nice. Okay. Will you share practice question and reference material? Yes, Shyam, that will be done after the class. Don't worry. Okay, okay. Thanks a ton, Rahul. Thank you. What about map? Yeah, same thing for maps. If you do like, if you take a map, you do the exact same thing. That's all. By now, it should be pretty clear that, maps and sets are very, very similar actually. So if you do like, you can't take it like this. And if you lower bound for 5, let's say this is 1, 2, like, okay, I'll not give it the value. So I'll just show you the lower bound. You can just do dot first. There you go. So you can take the iterator and you can take star iterator dot first or a dot lower bound 5. And this is just an operator that skips the star part. But yeah. Is this STL enough for that course? Which course? You mean TLE course, Sumit? Thanks, Atan Jayesh. Okay. Abhishek says, any tips on solving due to B and due to C? Honestly, just practice more problems and practice implementation more, actually. Speed is very important. Okay. Thank you, Shubham. Thanks a lot, Anand. Thank you. Okay, guidance on first 3 problems on CF. Okay, I see a lot of messages. I'll go through everything. I'm sorry. But yeah, just give me a second. Okay, so for the first 3 problems, Nehashish, first of all, start with 800 rated problems and increase your rating level, rating difficulty of the problems that you solve as, as you feel more comfortable with the whatever problems that you're practicing, right? So practice 800, then 900, then 1000 and so on until you become until you face a rating range that is a bit hard for you. That is the perfect rating range to practice, right? That's basically like the Goldilocks zone. Okay, Shubham says, do you have a YouTube channel? In fact, I do. Now I'll share it in the comment. 1 second. This is my YouTube channel. And yeah. Okay. Okay, we'll end the recording here. Let me just stop the recording.